Good day, everyone. I'm Ron Hawkins. I'm Director of Industry Relations for SDSC, and this is the October Industry Technology Forum. It's October already, hard to believe, but time marches on. For those of you who are just joining one of these for the first time, I'll mention that we normally do these as a local breakfast event, but for obvious reasons, we've been doing these online in recent months, and well, we welcome everyone who isn't local to San Diego and probably wouldn't be with us otherwise. So that's the silver lining in a dark cloud, I guess. So today we're going to hear from Bright Computing, and I was commenting yesterday when we did our technology check that I remember first bumping into Bright probably about 10 years ago, and they said they were a cluster management software company, and I was like, oh, yawn, cluster management. But that was a misplaced sentiment, because to use an overused word these days, Bright has really reimagined what cluster management is and can entail, and they've innovated with lots of interesting features, not just the for the kind of basic automation and management of compute clusters, but how you spin up and manage different kinds of clusters, like a Bright batch scheduled HPC cluster and a Kubernetes cluster on demand in the same hardware environment, or integrating on-premise clusters with commercial cloud capabilities, and even you running and managing clusters entirely in commercial clouds. So they've come a long way in 10 years and really put together a compelling portfolio of capabilities. SDSC is deploying Bright with its new Expanse supercomputer, which is expected to enter production within the next month or so, as well as our Triton Stratus interactive data analytics cluster. So with that, I am going to introduce Robert Stober. Robert is Director of Product Management with Bright, and I think he's been with them since the early days. So I think he'll not only introduce us to some of these interesting capabilities that I just mentioned, but also will be able to give us a good perspective on how the company's evolved and how they've come to think about this whole market segment over a period of rapid change. So with that, I will also mention that we are recording this session. You should have all received a notification, and we will end the recording after the formal presentation, and so you will not be recorded during Q&A if you prefer to not have your questions on the record. So with all of that, I will hand it off to Robert for today's presentation. Thank you.
Okay. Thank you so much for that warm introduction, Ron. See if I can make this thing full screen. Okay. So yeah, my name is Robert Stober. I am the Director of Product Management here at Bright. Like Ron, I also bumped into Bright about 10 years ago. In fact, I started 10 years ago as of January 1st, 2021. So I started on January 1st, 2011 with Bright. But I bumped into Bright before that, actually. So before I was a systems engineer for Bright, I was a systems engineer for platform computing, which makes the LSF workload management software. So I worked for them for 10 years also. And before that, I was in the technology development department at Siemens Westinghouse Power Corporation. I was a Linux admin there. So yeah, so I go back quite a ways in high performance computing. And I am really excited about what we've done at Bright, right? So we have been able to really push the envelope in terms of cluster management and take it to a different level by just thinking about what it is that's limiting the performance or what's limiting the job throughput, and then coming up with ways that that circumvent those problems, right? So, and we're going to talk about one of those today, which is Bright Autoscaler, which is actually a feature of Bright Cluster Manager. Actually, I think I'll just go ahead and jump right into the agenda, and then we'll talk about that. So we're going to have a little introduction. I'm going to tell you what Bright Autoscaler is, and then we'll look at the architecture, operations, basically how it works, how it's configured, and then an example. Yep, okay, so with that being said, so Bright's Autoscaler increases cluster throughput by repurposing idle compute nodes to pending workload subject to configured policies. So in a nutshell, that's what it is, right? So what do I mean by repurposing idle compute nodes? Well, repurposing is, for example, a node that's serving a certain HPC queue, right? Or partition, depending on which scheduler you're using, can be repurposed to serve a different queue automatically based on workload demand and according to the policies that you've configured. Or a node that's serving a Kubernetes, it's a part of a Kubernetes cluster, can be repurposed and made a part of the HPC scheduler in a certain queue. And vice versa, nodes that are in HPC that are idle can be repurposed to Kubernetes, and so on. Nodes that you can also configure queues to Cloudburst, right? To automatically instantiate cloud resources, workload runs on them, and then they're turned off, and so on, right? So Bright Autoscaler works on on-premise clusters, and it also works in the cloud, and it works across, it implements the hybrid cloud as well, right? So it's not just a hybrid cloud, but it actually repurposes on-prem nodes from one use case to another, depending on the policies that you've set up. So out of the box, Bright, it doesn't do anything, right? Until you assign the autoscaler role and configure it, it doesn't just repurpose your nodes willy-nilly. It only does what you tell it to do via the policies. Okay, so you got that out of the way. Here's some typical use cases. I think I touched on some of these already. Scale 2 or more HPC scheduler queues using on-prem compute nodes. That's one use case. Scale an HPC scheduler queue using cloud nodes. So that's where you have an HPC queue that's using on-premises nodes, but sometimes you need to burst out to the cloud. We do that. We have cloud bursting integrations with, we have cloud integrations with AWS and with Microsoft Azure and with Bright OpenStack, which is another product that Bright produces. Another use case, scale an HPC scheduler queue versus a Kubernetes namespace. So this is where you have, let's say, an HPC scheduler cluster. Let's say it's a Slurm cluster, and on that same shared infrastructure, a Kubernetes cluster, and this thing can repurpose nodes between the two based on workload demand and policies that you've set up. So each one of these is implemented using a different set of policies. And the most complicated one is the last one, which we'll take a look at. And then combinations, right? So you can auto-scale 2 scheduler queues against each other using on-premise nodes. When I say against each other, I mean they're both using the same set of nodes, right? So it just depends on the priority of the workload and the how much workload there is and the policies that you've got set up. But those scheduler queues can be auto-scaled against each other, and they can also burst to the cloud, right? So that's what I mean by combinations. So it's really limitless. You can't actually list all the use cases, I don't think. But we'll see. Okay, some terminology to get us started, because we do use some unusual and new terminology. So workload, this is new. Pending jobs or pods inside of a Kubernetes namespace. Pending jobs, obviously, we're talking about the HPC scheduler there. And then here's one, a role. So everybody's familiar with a role, but in Bright, this is our definition, right? It's a task that can be assigned to a node. So basically, there's a lot of different roles inside of Bright. There's roles that can be assigned. If you assign a node to the login role, then it becomes a login server. If it's a storage node, it becomes a storage server. If it's a provisioning node, you assign that that role to a node, it becomes a provisioning node. It can provision other nodes in the cluster and so on. So that's what a role is. And a lot of times roles have parameters that you can configure to control how they do what they do. For example, the provisioning role, you can assign how many nodes can be provisioned simultaneously by a provisioning server, which nodes can be provisioned, which software images can be provisioned, and a lot of the roles have parameters that you can configure, right? And this role that we're going to talk about, the scale server role, is no different than that. There's a lot of different options that you can configure. A compute node. Okay, so when I say a compute node, I'm talking about a physical node, an on-prem node, or a virtual machine, which may be on-prem or it may be in the cloud. A policy, the way to specify what you want to accomplish, and you do that by editing the parameters of the scale server role. A resource provider. Okay, this is a really interesting one. It's a pool of compute nodes that can be allocated. So you can have several kinds of resource providers. Basically, well, I guess we'll talk about that in a minute, but basically there's on-prem nodes and then there's cloud nodes, but they're implemented as a static resource provider, which means like an on-prem situation, you have a certain number of nodes, right? So it's static, and those nodes are assigned or reallocated wherever scale server wants to put them based on the policies and the workload. You can also have a dynamic resource provider, and a cloud is a good example of that, right? Where you can just create whatever nodes you need to be created in order to accomplish the tasks at hand, the workload that's pending, right? Those nodes are instantiated, they're provisioned, and when they're done, they're powered off, etc. Okay, an engine. An engine is it's what allocates the workload across the cluster. It's either one of our supported HPC schedulers, which would include Slurm, PBS Pro Community Edition, IBM Spectrum LSF, and Univa Grid Engine. Those are the supported HPC schedulers, and also Kubernetes as well. Those are all workload engines that are supported by this system. A tracker is a way to specify the workload and its nodes requirements. Essentially, the tracker is the component that actually watches the workload. It watches HPC queues, it watches Kubernetes namespaces, and it's what decides, okay, we need more resources here or there, essentially. And then CM scale is the actual name of the daemon or service that actually does the work. It actually scales the cluster. It actually, instantiates the nodes in the cloud. So it's a separate daemon. It's a separate daemon. Okay. And this is what the architecture looks like. So you'll notice that CM daemon is in the center of this whole thing. So CM daemon is the daemon that Bright runs on every cluster node, on the head node and on all the compute nodes too. It's really the brains of the whole operation. And it's what actually issues the commands that does all this, the commands that do all this. CM scale is a separate service that runs also on a cluster node. Usually it runs on the head node, but it doesn't have to. It can run on any node that is either a client, meaning you can issue commands, you could submit jobs from there, or you could kill jobs, etc. So yeah, it's a separate daemon, and it actually tells CM daemon what it wants to do, and CM daemon actually does it. So for example, if CM scale says, okay, we need to drain node 005, then CM daemon will actually issue the drain command for that node to close it, right? So CM scale doesn't actually issue the commands itself. It tells CM daemon what it wants to do. And CM daemon, you can see there's commands going everywhere, right? So it issues the commands to the workload management system, and also power commands and things like that to reboot nodes, etc. Okay, so let's see if there's anything else I want to say about the architecture. Nope. Okay. So here's what the configuration hierarchy looks. Note that it starts with the scale server role. Like essentially, this is the task that we're assigning to one of the cluster nodes, right? So, and inside of the scale server role, you have a hierarchy of configurations, right? So there's resource providers, which is an object inside of the scale server role, and the engines, which are all objects inside there as well. Notice for the resource providers, they can either be static. Again, that's like an on-premise cluster where you have a certain fixed number of nodes, or they can be a dynamic resource provider, which is the case in the cloud, right? Where you or in OpenStack, let's say, where you can dynamically create nodes, and those nodes become a part of the cluster, and they can be used to run workload, and then they can be powered on and powered off or removed, etc. And then for the engines, you have 3 different engines. I already mentioned HPC, so that's an HPC scheduler. I already mentioned the Kubernetes namespace. There's also a generic engine that is provided for extensibility so that sites like San Diego Supercomputing Center could potentially create their own workload engine, right? So if there's some other scheduler that you want to use, right, you can implement it using these Python classes that Bright provides by default. So they're already there when you deploy Bright. By the way, this is a feature of Bright. So anybody who has Bright Cluster Manager has Bright Autoscaler. Most people just don't know that they have it, or they're just not using it, right? But there are organizations out there that are using this, and we definitely hope that San Diego Supercomputing Center decides to use it too, because we think that we'll gain a lot of good information and knowledge about how to improve it even further, right? And that's always the payoff for somebody like me and the other members of our team who develop this and who believe in it, right? Okay, so there you go. So notice that for the engines, for you have the HPC, Kubernetes, and generic engines, and then below that you have a tracker. So a tracker watches a single tracker watches an HPC queue, right? And you can have more than one tracker for a given workload engine. So if you wanted to watch 2 queues or 3 queues or any number of queues, you can do that very easily, and you can auto scale all those things simultaneously, and you can cloud burst from all of them simultaneously, etc. There's also Kubernetes namespace trackers. So what we do is we track individual namespaces in Kubernetes, and when you deploy Bright Kubernetes, you end up with the default namespace, and usually that's what you track. And so, but if you have other namespaces, you can track those too, right? It doesn't matter what namespace it is. And then there's a generic tracker as well. Again, that's just Python code that we ship that you can then customize, and that would be the tracker for your generic workload engine. Okay, let's see here. So going on to the next slide, this is how it works, right? So CM Scale goes through an iteration periodically. By default, I think the period is 5 minutes, but you can set it to whatever you want. I set it to 1 minute, meaning that it goes through this process every 1 minute. And how often you have it iterate really depends on how long your workload is, right? So if your workload is short, then you're going to want a shorter iteration period. And if your workload is longer, of course, you don't need to have so many iterations, right? Because the workload is just going to keep running for a long time anyway. But it really depends on your policies, right? So let's say it's 60 seconds or whatever it is, right? So it starts the iteration. First thing it does is it connects with the workload engines, and it gets the demand information, right? How many jobs are pending? What's the pending workload in Kubernetes? How busy is Kubernetes, essentially, right? It calculates the priority of the workloads. It does have an internal formula. Essentially, it has an internal queue that it puts all this stuff in, right? And so it's got its own queue, and it has its own formula that it uses to get the priority of the workload. However, in Bright 9.1, which is due to be released later this month, it actually gets the priority of the workloads from the workload engine itself. So whatever the priority of a certain job is inside the scheduler, that's the priority that Autoscaler will use in Bright 9.1. So that's an improvement coming in Bright 9.1. And I have a slide that talks about all the improvements that we'll get to closer to the end. So then it fills the workload queue, basically. So it puts them all into a queue. And then it schedules nodes to run the workloads from its internal queue. So it'll actually map jobs to nodes, right? So it looks at the workload, it prioritizes it, and then it maps all the workloads to nodes. And then of course, it determines what operations are actually needed to repurpose that node. Typically, it'll drain the node first, so that no more jobs are scheduled to that node while it reboots a node or switches it from one use case to another. And then it actually sends that information to the CM daemon that performs the operations, and then that's the end of the iteration. Then another minute later, or whatever your period is, it starts over again. So it just constantly goes through this cycle over and over again, getting the workload, putting it in the queue, scheduling it to run workloads, and repurposing nodes as necessary in order to cause the workload to run. So the idea here is that if you can imagine, well, let's talk about silos for just a moment, right? So So a word that you hear a lot in the industry, right? So a silo, right? Generally, a silo is a set of resources that are being used for a particular purpose. And while they're being used for that purpose, they can't be used for another purpose. For example, nodes that belong to the Kubernetes cluster cannot be used to run jobs that are in an HPC scheduler queue, right? Those nodes are not running the workload management system daemons. And they don't know, and they're just not going to run any jobs, and nor does anybody want them to. I mean, it would be a bad idea to run Kubernetes, daemons and the workload manager daemons on the same node, because they'll both schedule workload to that node, and then that node will become overloaded, and all the jobs will run slower, and that's not increasing the performance of the cluster, and it's not increasing job throughput. It's just making everybody's jobs run slower. So the idea here is not to run both of the workloads, on the same node, right? But to move nodes from the Kubernetes cluster to the HPC cluster, right? Okay, so there's basically, those are rigid silos. Okay, so a Kubernetes cluster and an HPC cluster, they're two silos. Imagine them both running together on the same shared infrastructure, right? But what about the case where there's no pending jobs in Kubernetes, let's say, right? And there's idle nodes that are sitting there doing nothing, but the HPC scheduler queue has a ton of jobs waiting to run, and they can't run because there's no nodes to run, right? So what this system does is it changes the silos from being fixed, rigid silos, and it makes them dynamic silos. So it's not that the silos don't exist, it's just that it's taking nodes, let's say in this example, from Kubernetes and moving them to the HPC scheduler. So it's effectively resized both of the silos, right? It resized the Kubernetes silo, it made it smaller, and it resized the HPC silo and made it bigger, right? So you still have silos, but the silos are dynamic, they're not fixed, and it's all about keeping the machines busy, running workload that's ready to be run. And obviously, if there's no workload to run, then there's no need to move any nodes, right? So they'll just stay where they are. However, autoscaler by default does power off nodes that aren't in use. So if the nodes are just not in use, they're just sitting there idle. While they're sitting there idle, they're using electricity, and then of course they're using more electricity because now we need to remove the heat from the data center, right? So it's an efficiency that we built into it to power off the nodes that aren't in use, and then when somebody submits workload, power them back on. That is an option you can change if you don't like that, right? So it doesn't have to shut down the nodes. That's just what it does by default. So again, this is all about resizing the silos dynamically based on the workload demand and subject to the policies that you've defined. And it just does it automatically for you. By the way, you can also repurpose nodes yourself as an HPC admin, as a Bright administrator, right? So it's not like it's doing something that you can't do yourself. It just does it 24/7 automatically. Okay, so here's some operations that this thing actually runs. So drain a node. So, when you drain a node in a workload management system or in Kubernetes, it basically, it means the same thing for all of them, which it says, put this node in offline mode. In other words, don't send it any more workload. When a node is drained, no more workload will be sent to it. And then undrain, which is the opposite. Release the node from offline mode. So once a node is undrained, then the scheduler can send workload to that node again. Power off is obvious. This is a power off command, power on. And then terminate. So this one only applies to cloud nodes and virtual machines, right? So cloud nodes can be terminated. If a cloud node is terminated, then well, I'll say EBS volume, in the case of AWS, would be deleted, right? If it's terminated. And that also gives you the opportunity to set it to use a different instance type and so on. But that's not really related. So we'll go on. You can also remove a node. These are things that CM Scale does, right? It can remove a node from the Bright Cluster Manager configuration altogether. It can clone a node. So this again applies to cloud nodes and virtual machines. So, when you want to create when it wants to create a cloud node, it does that by cloning another node. So you can have different resource providers can clone different nodes to implement different, to be able to run different kinds of workload, essentially. And it can also assign a category. So if assign a category is configured, then when autoscaler moves a node because of that tracker, then it'll assign it to that category. And when you change a category, that essentially can change the operating system that's running on that node. So when you move a node from category A to category B, and category A is using the rel 7 image, and category B is using the slice 15 image, then that node is rebooted and it's reprovisioned to slice 15, right? So this is a super useful feature. There's also another way to repurpose nodes, and that is by changing the configuration overlay that it belongs to. A configuration overlay is a construct that we have in Bright that allows you to assign any number of roles, let's say one or more roles to one or more nodes, right? So one or more roles to any number of nodes, essentially, right? So when you move a node from the Kubernetes worker overlay to the, let's say, Slurm client overlay, right? Then what happens is the Kubernetes daemons on that node are turned off, and then the Slurm daemons, Slurm D and Munge, are turned on, right? So in that order. So moving a node from one use to another can be as simple as turning off one set of daemons and turning on another set of daemons if both of the nodes use the same software image. If they use different software images, then the node will be automatically reprovisioned to the new operating system that's required. Okay, let's see here. Okay, so the HPC workload scheduler integration. One of the things here is to set the job node location. So, once that set of nodes are selected for a job, of course, if you want to run an MPI job, you don't want to run the job using on-premise nodes and cloud nodes at the same time, right? Because the latency would be too high, the job would run slow. Essentially, what this does is it selects all the same type of node, whether they be cloud nodes or virtual machines or local nodes. And it's an option, right? You don't have to configure this, but most people do, right? I would recommend it, especially if you're running MPI jobs, right? And what it does, it tracks jobs that are in particular queues, and those are the queues that you set up in the configuration. You tell it to watch, Q Shark or Q Jaguar or Q Sharks and Q Jaguar, etc. Those are the queues that's going to get the workload information for. Any queues that you don't tell it about, it won't do anything to those queues, right? It won't get the workload for them. It won't allocate nodes for them, etc. And CM scale, that's autoscaler. It can start as many nodes as required, by the pending jobs, and it can move nodes between queues, and it can move nodes between configuration overlays, etc. So the Kubernetes integration, implements a namespace tracker. That's the tracker that watches a namespace. Of course, Kubernetes is totally different than an HPC scheduler in terms of the queue, right? It's not like there's it's a lot harder to get load information from Kubernetes, especially for HPC people, right? But our developers know how to do it, so they figured out this namespace tracker. It gets the job and pod information from Kubernetes, and there's a bunch of parameters that you can set that define whether or not a node is too busy to get a new pod, right? So it's not like job slots like you have in an HPC scheduler. But there's a CPU busy threshold with a default of 0.9. There's a memory busy threshold with a default of 0.9. In other words, 90% of all the memory is used up. There's a queue length threshold. There's an age threshold, and then there's a max pod. So this is on an individual Kubernetes nodes, you can run as many as 50 pods. Well, that's the default anyway. You can control this. You can set how many nodes, what the maximum number of nodes, what the maximum number of pods, is for a given Kubernetes node, and the default is 50. But again, you control all of these. If you don't like these thresholds, you can change them in the role. Okay. And then there's the generic integration, the generic engine integration. These are the custom Python classes that are distributed with every Bright cluster that you can use to create your own workload engine, right? So of course, it gets the workload from whatever the engine is and converts it to its own internal representation. It gets information about the nodes load, and how busy are the nodes from the engine, and it can drain the nodes in the engine. And there's an example distributed for both the engine and a tracker for the engine. And when you deploy CM scale, those examples are deployed for you too. So you can configure Bright Autoscaler using either the two administrative interfaces that Bright provides. So we provide the Cluster Manager Shell, or CMSH, to manage the cluster. And we also provide a graphical HTML5 web portal called Bright View. Either one of these can be used to administer the entire cluster. And you can also use it to configure Autoscaler, obviously. So here's an example of the CMSH. So here we are on my head node. We're in the role, submode, and scale server role, right? So we're showing the scale server role, which is how you define which node is running the CM scale daemon, right? So you can see the various parameters here that are there. Note the run interval there is set at 60. Debug is turned on, and that just provides more information in the cmscale.log file, which is very, very useful log file. It shows you what Kubernetes, what Autoscaler is actually thinking, right? What workload it got, how it's mapping the nodes, and the operations that it's actually providing, actually performing. Those are all listed in that log file, so you can watch the log file and basically see what's going on. Notice there's also an engines submode here, where two engines are defined, and there's a resource provider where one resource provider is defined for this particular cluster. Okay, so that's the CMSH, and then here's what it looks like in Bright View, right? So if you're in Bright View, this is the same information as you would have in CMSH that's presented in the HTML5 web portal. So depending on if you're a shell person or a graphical person, we've got you both covered. And you can actually use both of these. You don't have to use one or the other. You can use both of them. And I typically do use both of them, but different people, some people just use a shell, for example. Right, okay, so here's an example. Auto-scaling an HPC scheduler queue versus a Kubernetes namespace, which is probably the most complicated example that we could show. So there's a couple of policies here. First of all, we want to allocate the nodes to Kubernetes first and then to the HPC scheduler. So that's just a policy, right? So somebody says, okay, so which jobs are more important? Or, let's say there's only one idle node, right? Who's going to get it? Well, in this case, Kubernetes will get it because of the priority that we set up, and you'll see that in just a moment. And then here I'm also allowing a maximum of 8 cloud nodes in this configuration that you'll see. The graphic down at the bottom, it's just there to sort of try to get the point across that these are dynamically redefined silos, right? So in this example, the HPC scheduler shown in blue has 5 nodes, and then the Kubernetes, which would be the machine learning workloads, has the balance of the nodes. But of course, Autoscaler can move these nodes back and forth and resize the HPC queue and resize the Kubernetes namespace based on the workload demand, right? And the cluster that I'm using here is a cloud cluster, right? So that means that it's using Bright's cluster on demand technology. I'm running a cluster in Amazon Web Services. The whole cluster is there. The head node and all the compute nodes are there. So this will be a dynamic resource provider, meaning that I can just implement however many nodes I need, but I don't want to implement I don't want it to start an unlimited number of nodes, because that could, cause my cloud costs to go sky high, right? So I limit it to a certain number of nodes, right? And how many nodes you limit it to is just totally dependent on how many jobs you expect to run in the cloud, and what your cost structure is, and so on, right? So I'm going to show you how we implemented these policies here. Okay, so this is the example. Okay, so the resource provider. Notice I'm still in the scale server role, but now I went into the resource provider submode, and you see my resource provider. It's named AWS, which is some arbitrary name that I came up with, right? Because these nodes are in AWS. Notice the type is a dynamic. It's a dynamic resource provider. The template node is named cnode001. So that's the node that is used to create additional cloud nodes whenever needed. It's enabled, so you can disable this thing, and then it no longer is a valid resource provider anymore, right? So note the priority is set at 0. The priority is not important because I only have one resource provider. Now, if I had more than one resource provider, I could assign a priority to each one, and Autoscaler will look at the resource provider that has the highest priority first, right? So if I had 2 resource providers, let's say I had a local, on-prem resource provider, and I had a cloud resource provider, my policy would be to set the on-prem resource provider to have a higher priority than the cloud, that'll cause Autoscaler to run workload first using your on-premises nodes, and then to burst to the cloud if there's not enough on-premises nodes in order to satisfy the workload demand. The node range that I've defined here is nodes 2 through 9. So it can start nodes 2 all the way through nodes 9, and it won't ever do node 10, right? It's limited to those nodes. The network interface that it uses, I'm not going to go through all of these. It's Ethernet 0. Notice I've got it set to never start the template node and never stop the template node. That means you can reserve nodes for your own use, right? You can reserve nodes out of this that it just won't start or stop. You can turn them on and off yourself as the administrator, and you can turn them on and leave them on, and they can become a part of the queue and just used all the time if you want. Or you can just have some nodes that you reserve for testing or whatever. So these are all just policies that you can set up. Yeah, and so I think that's all I'm going to go through on this. The other settings are also useful, but it depends on your site setup. In my case, I'm just doing it very simple, one job slot per node essentially. If you have nodes with 4, of course you'd probably set that to 4, right, or 20, whatever it is. Right. So, okay, now we're looking at the engine. So notice that there's 2 engines defined. So in the scale server role, there's a sub mode called engines, and I'm using the Slurm engine here, and its type is HPC. So it's an HPC queue. The workload manager is Slurm, and the name of the workload manager instance is also Slurm. So starting in Bright 9, we allow you to create as many instances of a workload manager as you want. So you could define 2 Slurm instances and manage them both through Bright, or you could define 2 Slurm instances and 2 PBS Pro instances and manage them all through Bright, or you could just have 1 workload manager instance, right, which is pretty typical. But we have all kinds of flexibility built into Bright and into this particular feature as well. Notice that there's a tracker. It says 1 in sub mode, so there's 1 queue that we're watching in HPC, and we're running 1 workload per node. Note the priority is 1, right? Now, down below that, you see the Kubernetes type engine. It's the default. The name of the Kubernetes cluster is default, and the name of the namespace that we're watching is called K8s-default. There's 1 tracker, and there you see there the thresholds, the CPU busy, the memory busy threshold, and all those goodies are all listed there, right? Note the priority of the HPC engine is 1, and the priority of the Kubernetes engine is 2. So this means that it's going to first look at the Kubernetes engine and allocate nodes from there to there, right? And then it'll look at HPC after that. This is a policy, right? So this is how you implement the policies that you actually want. So you have to sit down first and think about, what do we want to happen? And then you just translate that into the priorities for the engines and for the resource providers. Right, so as a result of this configuration, so, I submit a bunch of jobs, right? I submit a bunch of Kubernetes jobs and a bunch of Slurm jobs, and Autoscaler goes to work repurposing the nodes. So you can see here, what it's doing is it's moving nodes. It's assigning nodes to the kube default worker overlay, and this is a configuration overlay, right? So there's a whole bunch of roles that are involved. When you assign a node to the Kubernetes default worker overlay, it gets a whole slew of nodes. Basically, it turns that node into a Kubernetes server, makes it a part of the Kubernetes cluster, it starts the daemons. And the same thing's true for the Slurm client. There's basically the Slurm client role means that Slurm D and Munge are running on those nodes. And as you watch this thing, you'll see it move the nodes from one use to another. Essentially, that's what it does. And it does it by using these configuration overlays, because basically when it moves a node, when it moves a node from Slurm client to Kubernetes, what it does is it first drains the node, and then it turns off the Slurm D and Munge, and then it moves the node into the kube default worker overlay, which causes it to start the Kubernetes daemons, and then it gets undrained. And now it's ready for service, right? So Kubernetes will see it as a valid node, and they'll start dispatching workload to it. And it just does this automatically. this is what the log file looks like. So notice the debug mode is turned on. So all those messages that say debug, you wouldn't see those unless we had debug turned on in the scale server role. But notice it's got all these nodes and it's mapping workload to the node. So those are the job IDs, Slurm 4263, for example. It's got that map to C node 002. And then it goes through and performs operations. In the case where all these nodes were turned off, let's say, it'll power them on, or if they were running Kubernetes, it has to reboot them. So you can see it powers them on, and when they come up, they're in the right overlays, just like that. So, okay. So what's coming in Bright 9.1? You know, we're really excited about this feature, and since people have started adopting it, of course, we've gotten some valuable feedback, and that tells us what we need to change, right, to improve it, the way that it operates. And so there's a whole slew of changes that we've done here. Number one, Autoscaler in Bright 9.1 now provides hooks that can be used to run a site-defined script when the node is allocated or when it's returned to the pool. Right, so these can be scripts that do whatever you want it to do, right? Maybe you need to, I don't know, run some kind of security protocols or something on the node when it gets moved from one to the other. So we've implemented these hooks, and we've made 2 efficiencies to increase the job throughput even further, right? You know, beyond just taking an idle node and making it, you know, do some useful work. Okay, the first efficiency is that we want it to first look at the nodes that already have the right software image. So if it's got a choice between 3 different nodes that it could allocate, instead of just choosing the first node in the list, right? Look at the nodes which already have the right software stack required by the workload, and then allocate those nodes first. And what that does is it saves rebooting the node, right? So if you don't have to reboot the node, then you save all that time it takes for the node to go through its BIOS, to load the operating system, and become ready to run workload, which could be 3 minutes or it could be 5 minutes, right? So saving 5 minutes is, you know, it adds up to more job throughput, more production out of your cluster. Also, don't reboot the compute nodes when repurposing them from one engine to another if they both use the same software image. Right, so if Kubernetes and HPC queue are both using the same software image, then there's no need to reboot them when moving from one to the other. It's just a matter of turning off some daemons and turning on another set of daemons. And so there's another efficiency that we're gaining in Bright 9.1. The trackers now take a prioritized list of pools. So in other words, each tracker has a list of resource pools that they can use, and an individual priority list for those pools. So let's say you had an on-prem pool called local, and let's say that Kubernetes can use that queue, or it could use the cloud, but we set the priority for that pool to be 20, let's say, and 10 for, so 20 for on-prem and 10 for cloud, or, you know, 2 and 1, whichever you want for the prioritized list. But then the HPC scheduler can see a whole different priority for the same pool, right? And you can limit which ones they can use at all, right? So this is an important feature that gives a lot more control over the system. It's a very important new feature in Bright 9.1. And this is a really good one, right? Autoscaler now retrieves the job priorities from the workload management system itself, right? So people go to a lot of care and effort to configure their workload management system with fair share and all sorts of you know, cool scheduling algorithms and policies. And so what we're doing here is we're just saying, look, let's just get the priority from the workload management system and use that priority. You know, it's an option that you can use, or you know, or maybe you just like the way it works out of the box, one way or another, right? But so that's a new feature as well. We also have a new graphical autoscaler setup wizard. You've seen the CMSH setup routine. It is easy to configure, but it's also very new to people who haven't used it before. So like we do for the installation of the whole cluster itself, and like we do for the setup of the cloud providers, as we do for the setup of Kubernetes and Ceph and the edge and so on, we've now added a graphical autoscaler setup wizard that will just ask you a series of questions and then configure autoscaler for you automatically. So it'll ask you what scenario that you're trying to set up, and then it'll go ahead and set that up for you. And then you can edit it after that any way you want. Also, Autoscaler is now also retrieving the job resource requirements from the workload management system. So that means that amid a job that requires 128 gigabytes of RAM, Autoscaler will only give you a node that has at least 128 gigabytes of free memory, right? So that just makes sure that the node that Autoscaler assigns actually has the resource requirements to run the job, right? Otherwise, it doesn't do much good. So previously, we worked around this by creating different resource pools. So this is going to obviate the need to do that. And like I said, this stuff is coming out later this month. And finally, I'm going to close with this short discussion of the edge. So in Bright 8.2, we added a feature called Bright Edge that allows organizations to deploy, to manage many different locations as a single cluster. So for example, if you had a location, let's say that's in Austin, Texas, and you have another location that's in Portland, Oregon, and another location that's in Paris, France, let's say, right? So typically before Bright 8.2, those had to be managed as separate clusters, right? So in Bright 8.2, no, you can manage all those as a single cluster using Bright Edge. And of course, you know, we got the name because of IoT or IoT, right? So it's for edge locations. You can have thousands of edge locations and manage them all through Bright. Well, Autoscaler, the point that I want to make here is that Autoscaler also works on edge locations too. So you can repurpose nodes that are in remote locations that are still part of your cluster, of course, because of edge. Just like you can repurpose nodes on your local on-prem cluster and in the cloud, right? So it's extended all the way to the edge as well. So that's my presentation for today. I thank you all for attending. And if there's questions, I guess this would be a good time to address those.